Ford expects to boost its global electric car production capacity to 600,000 units by 2023, making it the second-largest U.S. electric vehicle producer after Tesla. But to do so, Ford must conquer the battery supply chain. The American manufacturer has announced that it'll be upgrading the electric vehicles it produces with a new LFP battery composition that will boost capacity and reduce manufacturing costs. But how does Ford intend to achieve this massive feat? Join us today as we take you through Ford's new lithium iron phosphate battery that has shocked the entire car industry. But before we continue, we need to know what LFP batteries are and the difference between the current industry standard NMC and NCA batteries. NMC nickel cobalt manganese and NCA nickel cobalt aluminum have been the gold standard for years. They are lightweight, powerful, and can hold lots of energy, which allows for longer ranges. But there are two big drawbacks. They can be flammable, and they also use exotic and increasingly expensive raw materials. These include nickel, cobalt, and manganese. Due to increased competition in the EV market, prices have risen ninefold from $6.75 per kilogram in early January 2021 to over $40 per kilogram in 2022. The big difference is that LFP does not use the same expensive raw materials. They use lithium, iron, and phosphate chemistry. Early LFP batteries were significantly less powerful than NMC and NCA alternatives. They were mainly used for e-bikes and low-end EV brands. Despite their potential benefit of being less expensive, they couldn't achieve the results needed to compete. LFP chemistry accounted for just 3% of EV batteries in the US and Canada in 2022 and 6% in the European Union, with nickel cobalt manganese and CM cells accounting for the rest, according to data from Benchmark Mineral Intelligence (BMI). But in May 2021, China made more lithium iron phosphate LFP cells than nickel cobalt manganese NCM cells, marking the first time LFP had surpassed the production of NCA or NMC batteries. This signaled that the benefits were starting to outweigh the drawbacks that had held back the adoption of LFP cells globally. In order to compete on a global scale, it's essential that Ford has access to sufficient supplies of raw materials needed for batteries. This is why they've just agreed on a huge supply deal with China's largest LFP manufacturer for lithium iron phosphate batteries beginning in 2023. The cost and longevity of LFP batteries have made them particularly popular in China, where affordability and reliability are more important to customers than overall driving range. Because iron and phosphorus are abundant almost everywhere in the world, LFP cells are at least 30% cheaper than any other option, including NMC, NCA, and NMCA cells used in many EVs today. Compared to nickel-rich batteries, LFP batteries last a lot longer. They can be charged and discharged hundreds of times without losing much of their power. CATL confirmed that its LFP cells can go 1,000,000 kilometers before needing to be replaced. Nickel-rich cells, on the other hand, are approximately 30% less efficient. Nickel prices have doubled over the past year, mostly due to the conflict in Ukraine. Right now, Russia provides about 10% of the world's nickel, and 20% of this nickel is used in EV batteries. Many automakers have had to increase the price of EVs as a direct result of increasing raw material costs. Ford has already increased the price of their F-150 Lightning twice this year. For example, the starting price of the 2023 Lightning Pro model will be $51,974, up nearly 11% and a 30% increase from the truck's $40,000 price in May 2021. Even though LFP cells have less energy density than nickel-rich cells, this problem can be fixed by using new cell-to-pack structural designs. These designs get rid of the module structure, making it possible to pack more cells into the same amount of space. All Tesla Model Y and Model X vehicles made in China over the last 2 years have been fitted with LFP batteries, as the Chinese buyer cares more about durability and price than range. Tesla then shocked everybody when their Q1 results showed that they had used LFP batteries in more vehicles than anybody had thought. Nearly half of Tesla vehicles produced in Q1 were equipped with a lithium iron phosphate, LFP, battery containing no nickel or cobalt, Tesla confirmed in a statement. Elon Musk's company has now shifted to LFP batteries for all standard range vehicles globally. Like Tesla, Ford will likely use LFP batteries for its standard range vehicles and keep using NMC batteries for its extended range packs. CATL is the largest provider of electric vehicle batteries in the world. They offer LFP cells that Tesla, and now Ford, use in their EVs. Ford has confirmed that LFP will be used in some of the Mustang Mach-E models beginning in 2023, and the first iron phosphate-equipped F-150 Lightnings will roll off the assembly line in early 2024. Ford will have to do this if it wants to reach its goal of making 2 million EVs per year by 2026. The first production will come from CATL factories in China. However, Ford plans to localize the production of 40 gigawatts of LFP in North America by the end of 2026. This will be in addition to the 129 gigawatts of NMC that will come through the company's joint venture with SK On. Ford has found all of the batteries it needs to make its goal of producing 600,000 cars by the end of 2023 a reality. This was made possible by the inclusion of CATL's LFP batteries, which are now in production. CATL has also signed a contract with Ford for 70% of the batteries needed to meet its goal of 2 million electric vehicles by the end of 2026. To take the lead, you must cover every area. This is what Ford is planning on doing. Ford is investing directly to get raw materials, just like General Motors, Volkswagen, BMW, and other companies have done. It has supply agreements with BHP Cobalt, and both Vale Canada and PT Vale Indonesia for its nickel. In addition, Ford has supply agreements with Liontown Resources and Rio Tinto, both of which are based in Australia. Due to problems with the supply chain over the past 2 years, Ford is also trying to make it easier to get cathode materials like lithium closer to home. This shows that relying on a single supplier for anything can be difficult. EcoPro BM and SK have signed an agreement before to make materials for cathodes. Ford also has contracts with Pioneer and Compass Materials to get lithium from North America and with Sierra Resources and SK to get graphite from a factory in Louisiana. Ford has also agreed on a deal with Redwood Materials to recycle its batteries. Ford CEO Jim Farley is doing everything he can to make sure Ford is not left behind during this electric vehicle revolution. He recently said during a CNBC interview, "We're not going to cede the future to anyone." Because range concern has been one of the most critical elements in EV consumer purchasing behavior, NMC-based EV manufacturers have concentrated on and produced more energy-dense cells to meet customer demand. But nickel and cobalt have become bottlenecks for NMC battery production, and EV drivetrain efficiency has improved to the point where less energy-dense LFP batteries can match the range expectations of consumers. As a result, NMC batteries are losing market share to LFP batteries. Research also shows that neighborhood electric vehicles with shorter ranges will acquire market share, reducing the demand for energy-dense NMC batteries even further. Ford's switch to LFP batteries probably won't stop future shortages of materials because lithium itself could become a bottleneck. But if the past is any indication of the future, the chemistry of batteries will continue to evolve as scientists look for the most cost-effective way to meet market demand. What do you think of Ford's latest move? Do you care more about range or price? Let us know in the comments below. Thanks for watching to the end. If you haven't yet, please consider subscribing to our channel so we can keep you up to speed on Ford, Tesla, and EV news.